And if you look at this picture, it shows them drawn together. And if we pay attention to the wording on the other side of the page, it says it sticks to block B. Okay, so they're traveling together. Anytime you have things that stick together, that kind of should remind you of inelastic collisions. Okay, and that tells me in part D, I probably need to think about conservation of momentum. So, first of all, in order to find the distance this travels, I need to find out how fast these guys were going as they left the table. Okay, as they're falling, momentum is not conserved. And that might seem a little confusing. How can I use conservation of momentum if momentum is not conserved? But momentum is going to be conserved for just a small instant. It's going to be conserved from, and I'm going to draw a before and after picture. So they're both on the table. It is going to be conserved from the instant before A hits B, that's my before picture, to the instant just after they hit. So before they've really even left the table, they're stuck together and they have not yet left the table. Momentum is going to be conserved. Okay. I want you to take a minute and decide, after momentum is conserved and we find this velocity using sigma p naught equals sigma p, after we do that, how are we going to find the distance d? What concept are we going to use? And write it down. Okay, so if I know a velocity and something is flying through the air and I'm looking for a distance, chances are I'm going to have to use 2D kinematics. Okay, so for the end part, at the very end of part D, in order to calculate what I want at the end, I'm going to have to use 2D kinematics with delta xx, delta xy, etc. Okay, part E. It says, consider the system consisting of the string, blocks, and table. How does the total mechanical energy, and mechanical energy is just spring potential, kinetic, and gravitational, E2 of the system just before the blocks leave the table compared to the total mechanical energy E1 of the system just before block A is released. And I want you to take a minute and actually answer that question and write it down in the Google form. Okay, so if we think about it, energy is going to be conserved as long as there's no heat or work. Okay, so if there's no heat or work ever, then E2 equals E1. Okay, there's one place here where there's going to be heat. And the place where there is heat is when block A crashes into block B, it's going to generate heat because it is an inelastic collision, or because it's it's not totally elastic. Okay, what that means is mechanical energy is lost when they collide, and it means that E1 is bigger than E2.